Don't start thinking about math, just read it. What's it about? Cube. That's all I want you to get on the first time through, because what is your brain now doing, even though you didn't ask it to? Thinking about a cube. So your brain is already processing what does it look like, what are its components, what are its properties. It's picturing probably a box like the picture. It's figuring out it's got 6 sides, even though you didn't ask it to. Let's pick out the keywords. Okay, what do you want to do? Okay. Four times something. 4 times 4 times 4 is the offer. Well, that definitely has something to do with exponents. Would that give us surface area? 4 times 4 times 4. That's giving us the volume. So that's our 3-dimension. That would be for the cube, not what the question wants. The question wants just the surface area. Well, what's the area of a square?
This square is
4 times 4, and how many squares do we have in this cube? So we know that surface area has to be 6 times the side length squared. That's where this unit's coming in, is the fact it's a squared, Brody. What is the side length of the square? Now we're practicing yesterday. Can I say this is 24 squared? Why not? 6 times 4, 24. What's the problem? 24 squared. This is back to bed math, so we have to do exponent first. So 4 times 4. 16 times 6, that's about the highest we would ask without a calculator. So split 16 into 10 and 6. What's 6 times 10? 60. And what's 6 times 6? Take your 60 and 36, poke them back together. And then we need some kind of units because it's a word problem. Centimeters squared. Usually it matches the exponent in the question. That's how you can usually tell what the units are. Read to read number 2. What's it about? Yep. What do we really need to know? Nothing. Forget it. We can do this question without anything. Inscribed is one of those fancy math words. You really don't see that many places besides in mathy kind of contexts. What does inscribed mean? What does it mean to inscribe 2 shapes? Yeah, put one into each other. That's all it means. It means there's a circle sitting inside a square. So if you didn't know what inscribed means, just make a note. It means inside. Inscribed, inside, same thing. Because it's just fancy math lingo. We like to sound all smart and fancy. Shaded region, what does that mean? Yeah, the black part. So anytime actually you have a shaded region question, you're going to find the area of the outside minus the area of the inside. That's the way they're always going to work. So area of outside minus the area of the inside. What I always do then is break it down into the shapes. What side is the outside shape?
Square.
It's a square. So I tend to just draw this square just to remind myself. I need to figure out that formula in a second. And what's the shape of the inside figure? It's a circle. So I'm taking the area of the square minusing the area of the circle. What's the formula for area of a square? Except that's a rectangle. side squared. Why do I not need the 6 that I used above? This was a cube. This is just a square. It's two-dimensional. What's the formula for area of a circle? Yep, pi r squared. That's what it has to do with this unit, is the fact they're squared in both of them. What do we know about the side of the square? Only 2, though, because it's two-dimensional. Here's where the tricky part gets, is we have the radius, but it's kind of hidden in the question. How can we find the radius when we only have the side length of the square? So it's how tall the circle is or how wide the circle is. So if we go right across here, we know this distance also has to be 20. How does that help us find the radius? It has to be half. So this is going to be pi times 10 squared. $20 squared, you'd be allowed to use your calculator for that one. If you know it without your calculator, that's great. For 4,000.
Oh, no. No,
400. What do I do first here? The multiplication by pi or the exponent? Do the exponent first. So what's 10 squared? That you should be able to do without a calc. 10 times 10. Next, I'm going to do that multiplication. This would be a calc question if you don't know what pi is. Generally times 100, it's not too bad, but if it was a different number, you could use calc. Now remember, you've got a pi button on your grown-up calculator, so you don't type in 3.14. That's out now in grade 9. Look at your calculator and try to find where the pi button is. Okay, it totally depends on the calculator in front of you. Could be on the left, could be on the right, could be a second function, could not be, but you need to locate the pi button. Just hang on one sec. Does everybody have the pi button? So all you're going to type is 100 times and then hit your pi button. 100 times, hit pi, then hit equals or enter. 100 times pi. 314 point. You just got that's as many as I got. Questions so far where any of the numbers came from? If the question doesn't say, typically we give it to 1 decimal place. If the question said, then we would have to follow those instructions. So now is our subtraction. 400 minus 3.14159.265, blah, 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 blah. Can't be negative because we're doing a bigger number minus a smaller number. It's waiting for an offer. Like, it's a subtraction. Like, just do it on your calculator. It's not that hard. To 1 decimal place, since the question doesn't say. That sounds confirmed. Can we get some units? So that's geometry. We're going to leave that and go to biology. So if you're into science, there's lots and lots of math in science. Read to read. Don't overthink it. Don't start thinking the math. Just put the context in your head. "30 seconds, turn and talk to someone and tell them why would biologists care?" Okay, why would biologists care? Why? Why? A little more specific. You're kind of on the right path there. What's an epidemic? Have you heard that word before?
Yes.
What does it mean, epidemic?
It's when a virus gets out of control and they're trying to contain it.
And so sometimes they'll declare either city epidemics or province epidemics or world epidemics. What was the last world epidemic that we had? What virus?
The South America new thing.
Yeah, the South American new thing. Which
Whatever it's called.
I'm blanking too. It starts with a Z.
Yeah.
Say it again. That's it. And why is that a problem? What was the problem with that virus? It wasn't killing people. Yeah, it was making babies deformed. And so you were somewhere, you got bit by a mosquito, 9 months later you have a deformed baby. Well, obviously that's an issue and they want to try to control that. So they classify that as a world epidemic. What does that mean? Well, it means they get more funding to deal with it. Yesterday, Children's Hospital declared a flu epidemic. So what does that mean? Well, they're seeing tons and tons of cases of the flu. If they declare it an epidemic, they get more funding from the government to have more nurses, more doctors, more staff. So it's important in terms of medicine and just in terms of controlling the world. The problem with this is we don't want to have to take the 100 and go times 2, times 2, times 2, times 2, times 2, times 2 to figure out a full day. Okay, that's great, but that's going to take you how many minutes when you don't need to? That's when exponents become involved, is to make it shortener. Grab your red pen. Here's how all the biology questions are going to work. The population is going to equal the initial population times a number that I'll explain in a second to the exponent n. The population is going to equal the initial population times some kind of number to the exponent n. P stands for population. I stands for initial population. What does initial mean? At the beginning, how many there were before we started carrying or counting. The number is what we call the multiplier. The multiplier. And that's going to end up being the base to your exponent. And that just depends on what the question says. If it's doubling, what is that multiplier going to be? 2. If it's tripling, if it's quadrupling, what if it's halving? 0.5, right? So that just depends on the questions. So you're looking for words like doubling, tripling, etc., etc., etc. N stands for number of. What do you think there? Number of what? That will be the population. Weeks or hours or days, depending on the question. So in general, we say N is time. Formula looks a bit confusing and crowded at first. You'll see once we do a few examples, it's really, really easy, and it's going to be the same every single time. Bacteria doubles every hour. There are currently 100 in a petri dish. How many will there be in 5 hours? In a day. What's the key information I need to know? In reality, I don't really care where they are. That's more the biologist. The mathematician doesn't care if they're in a bowl, a bucket, a can, whatever. But there is another word with 100 that is important. Currently, because that's going to tell you that's the initial. And then we care in 5 hours, and we care in 1 day. So let's set up our formula. Population is what we're trying to find. We need the initial value. How many were there at the beginning when we started counting? 100. What's our multiplier? Is it halving, doubling, tripling, quadrupling? So it's 2. And n is the number of hours that we don't know, which we'll sub in 5 in a second. So for the first part, all we're going to do is take out n and put in 5. What does it have to do with this unit? Well, this is now back to order of operations. Can I do this 100 times 2 first? No, I need to do the exponent first, so I'm going to leave the 100. 2 to the 5 you should be able to do in your head, so 2 times 2. 4 times 2 times 2 times 2, 32. 100 times 32. And we just need a word that describes what this is. 3,200 what? Bacteria. In a day, it's going to use the exact same formula up here, but instead of putting in 5, what are we going to put in for n? Why 24? 24 hours in a day. This would be a calc question because we wouldn't expect you to multiply 2 24 times. When you're putting this into a calc, you need to do bedmass as well. So you're going to do the exponent first. So you're going to go to whatever your exponent key is that we've talked about before, 24, then hit enter or equals, then times 100. So you're doing the exponent first, 2 exponent 24 equals enter, whatever you have, times 100. Offer. Looking for an offer. It is going to be big. Does that sound confirmed before I write it down? Okay, give it to me again then. 100. So that would be 1 billion then? Because 100 million is a billion? Okay, 1 billion, then? 600. Yeah. Can someone just double check that I copied that down correctly? Is that confirmed? That's a lot of bacteria. No, I think that is the times 100. Questions so far? Mosquitoes. We definitely care about tracking mosquitoes. How does the city track mosquitoes? How many they catch. And then somebody has to physically take them out and count them one by one. Why does the city care how many mosquitoes we have? Well, they carry disease, yes, but that's not really why the city cares. The medical people would care. What does the city do with this information? So why would your city be counting mosquitoes? Not so much. Probably is, but no confirmation on that. What does the city do for you at night in the summer? Yeah, they fog, right? How do they know if they're going to fog? They count the number of mosquitoes. Which, by the way, we're out of the chemical we use for fogging, so we don't actually know if we can fog this summer. And if you have never lived in a place where they do not fog, it is unbearable. It's unbearable. What do we really need to know? We need to know starting population, 100. It's chemicals, and it comes out of a truck. And because they can't actually buy it anymore because it's illegal, because it's harmful to some kind of animal. I don't know what. Not humans, but something. And yeah, so they can't find it anymore. They usually fall, like you probably have never been awake. It's usually like 3 in the morning. You can hear it if your windows are open. And so one time I was coming home late from something, and I like waved to the guys all excited, "You're fogging my street, yay." So excited. Okay, what else do we need to know? Starting population, 100. Quadruples. Population equals, let's put in the initial population. Then we need our multiplier, 4, and n will be the number of weeks. Okay, so that's our general formula. Let's plug it in for 4 weeks. Well, why can't I do 4 times 100? Bad math. Again, your brain's going to see that and want to do it, but we know we need to do our 4 cubed first. Do that in your calc. Right, 4 to the 4. You're right, I said cube too. Do 4 to the 4 in your calc first. Brody, there's no way you need to move your thumbs that much to put in 4 to the 4. But you just turned to it. I saw the screen light up. Sneaky. How much? Just confirm that part first. Okay, times by 100. Units. Mosquitoes. How many does there have to be in the trap before the city will fog? Does anyone know? Lower. There has to be 500 in 3 24-hour consecutive periods. So 3 counts in a row, they have to get at least 500, then they'll fog. Can you imagine the person that has to sit there and count 500 dead mosquitoes? Like, that does not sound like, no, they do it by hand. They have to do it by hand. That's not fun. What do you do all day? I count mosquitoes. They probably do, but still. Yeah. What do we do for 3 months? Why do we assume 12? Where's that number coming from? 4 weeks in a month, 12 weeks in total. How do we put this into our calc? Because we don't start with 100. What do we start with? 4 to the 12, then times 100. 216. Is that times 100 already? Yeah, but then because of the placing, we got to move everything over.
So 1,677,700.
1 billion.
677 million.
Okay.
721,600.
Can we confirm that? 1 billion, blah, blah, what now?
Yeah, it's the same answer.
Is it really?
That's the bacteria.
Shut up.
Multiplied by 100 and
Well, that totally is. That's coincidental. Cool. I would not want to count 1 billion mosquitoes. How many weeks did it take the mosquito population to reach 12,600? What do we do?
divide that by 100.
Well, I'll go back to our formula. This time I'm not subbing in n. What am I subbing in?
12,000.
P. I have P this time. I have the right-hand side. First thing I want to do is get rid of the 100. How do I get rid of a multiplication by 100? Yes, but what am I doing mathematically? I'm dividing by 100. Now what? Can't divide by 4 because then this exponent would be hanging out there all by itself. But how? It's an exponent, so dividing it's not the opposite of that. This is where we need to use a little bit of guess and check. If I pick 2 as a number and I put it in here, am I going to get 128? Is 4 to the 2 128? So I know 2 is too low. Give me another number. 4. Let's try 4 to the 4. What did 4 to the 4 give us? Too high. So what's a better guess? 3. Let's put in 4 to the 3. So we know it needs to be between which 2 weeks? 3 and 4, so 3.5 weeks. I'm just going to jot down what we talked about there, so when you look back, you know where it came from. We started with 4 to the 2, which we said was 16, so that's too low. We did 4 to the 4, which was 256. That's too high. We went in between, which was 4 to the 3, which is 64. So it's got to be in between the 3rd and the 4th week. Read to read. What's it about? Frogs. Let's pick up the key information.
96 frogs, triples yearly. Oh, population. 96 frogs, triples. How many frogs would be in 5 years, 50 years?
Turn and talk. Find a friend. Give me about 2 minutes.
I have almost less computer, but I give up. I'm done. That hurts my brain. I'm gonna go play pool. It hurts my head. I don't like it.
Why did I put 96 here? No, you can't even see why I put 96 there.
Oh, there's 96 frogs.
Why did I put a 3?
Because it's triples.
Stick in the 5. Give me the number.
That one is 23,000. Oh, whoops, 243.
Times 96.
Times 96, yeah. Which is 23,328.
28. Just looking for confirmation on the 23,328. Now that's not actually realistic in the real world, because what's going to happen to some of these frogs? Some are clearly going to die, so we don't actually do population this way. We account for what's called the death factor, but we're not going to get into that. What about in 50 years?
We started off with the 96.
Okay, so just tell me what your calculator said.
7.1789798769119E plus 23.
Did everybody get something that looks like that? Your calculator might be slightly different. I'll tell you in a second.
At the end, mine says times 1023.
Okay, times 1023, you might have that. You might have a few less decimal places.
Means it's 23.
So this is called scientific notation, which you'll learn about it in science if you haven't already. And it's just a short way for the calculator to give you really, really big numbers. What the E means is times 10. So the way we would write this is 7.2 rounded to 1 decimal place times 10 to the exponent 23. That's a quick way of writing 7.2 and then timesing it by 1 with 23 zeros. I don't even know what number that is. What do we call a number that has 23 zeros? I don't know. It's called scientific notation because it's just a short way of writing it. It means really, really, really large amounts of frogs. We forgot the units for both of these, though.
How many times yeah, we didn't times it by 96.
Oh, that's not times 96. Okay, so times it by 96 now.
Oh, great.
And then you'll still get 1 with an E, and that's okay.
6. But don't we need to do the exponents first to be inside?
But you did that already.
Oh, right. So times
6 point.
6.8918.
So can I say 6.9 to 1 decimal place?
Yeah.
And then times 10 to the, grab the last number at the end.
25.
Can we get confirmation on that? We don't expect you to write it out with 25 zeros. That's the point of scientific notation. It's a short way of writing out really, really big numbers. Units.
Frogs.
That's
That's a lot.
a lot of frogs that don't die for 50 years, apparently.
It's a good lifespan for a frog.
There's probably some, like turtles last forever. Maybe frogs do. I don't